Section 3.3 is talking about various angles in triangles. So more specifically, we're going to look at the angle sum theorem today, or the triangle sum theorem, and the exterior angle theorem. So an exterior angle, it's an angle that's formed by one side of a triangle and the extension of the other side. So if we're looking at angle 4 here, so here's the one side of my triangle, and we would actually be extending this base side to form that exterior angle. Right? There's more than one exterior angle for every triangle, because I could extend each one and then create another exterior angle. So if I were to extend that one, we could have an exterior angle there. If I were to extend that side, we would have an exterior angle there, so on and so forth. We could extend this side, create one, all the way around. So when we are creating those exterior angles, we have something that's called remote interior angles. And it's the interior angles of a triangle that are not adjacent to the given exterior angle. So if here's my exterior angle, angle 3 would be adjacent. So angle 3 would be our adjacent angle. So that leaves 1 and 2 to be our remote interior angles. And we're going to find out here in a little bit that there is a relationship between this exterior angle and these two remote interior angles. And finally, because we have a couple corollaries today, so a corollary is just a statement that can be used as a reason and a proof. So it's sort of like a fact or from a theorem. So let's take a look at the angle sum theorem. We did discuss this just very briefly in section 3.2, but what the angle sum theorem says is that the sum of the measures of the angles of a triangle is 180 degrees. So no matter what shape the triangle is, what kind of triangle it is, if you add all three angles, it will always add up to 180 degrees. So using that information and some things from the past, we're going to figure out example 1. So it says find the missing measures of the figure to the right. So we have angles 1, 2, and 3. I'm going to go ahead and start in order, but you won't always find all of these values in order. Sometimes I might have to start with 3, sometimes I might have to start with 1, and then 2. So just find them however you can. But I'm going to go ahead and start with 1, because if I look at 2 or 3, they're both in the same triangle, and I would need at least 2 of the angles to try to find the third, because then I could use that angle sum theorem. But we don't know 2. We do not know that 2 and 3 are the same. If they were the same, we could do it. But since we don't know any of that information, we can't start with 2 or 3. So let's try starting with angle 1. So angle 1, if we're looking here, it's part of this triangle. And we do know 2 of the 3 sides. So to find the third side, we would add those 2 and subtract from 180, because the measure of angle 1 plus 43 plus 74 adds up to 180. So the measure of angle 1, I'm going to take 180 minus 74 minus 43, and we find that the measure of angle 1 is 63 degrees. So now we have 63 here. So now we need to use that 63-degree angle and something that we've previously learned to find the measure of angle 2. Well, that angle 1 and angle 2 are vertical angles. So we know, or we remember, that vertical angles are congruent. So the measure of angle 1 is 63 degrees. That means that's what the measure of angle 2 is. So we know that the measure of angle 2 is 63 degrees. And now if we go back to what we were saying at the beginning, we can find the measure of angle 3 now, because now I know 2 of the 3 angles of that triangle. So if I add them all up, I'll be able to find the third. So the measure of angle 3 plus 63 plus 79 is equal to 180. Subtract 79 and 63 from 180, and we get 38 degrees. So that was sort of like a mini puzzle to try to find all 3 of those angles. The next theorem, a lot of students tell me makes sense to them because it says if two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangles are congruent. So let's say that with some numbers. So if I told you that A is, 60 degrees, but it's congruent to F, so F is also 60 degrees, and that C is 40 degrees, and C is congruent to D, so that's also 40 degrees. The triangle sum theorem says that B needs to be 80 degrees, which doesn't really follow suit for the obtuse triangle, but you get the idea. So it says if two angles are congruent to two other angles, then the third angles have to be congruent to one another as well. And finally, the exterior angle theorem. This was the relationship I was talking about at the beginning. It says the measure of an exterior angle. So here's my exterior angle. We'll call it 4. I'll number all of the angles. So 1, 2, 3, and 4. The measure of the exterior angle, so the measure of angle 4, is equal to the sum of the measures of the two remote interior angles. So my remote interior angles are the ones, let me make that look a little better, the ones that are not adjacent to it. So the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. Okay, so now let's take a look at example 2. Again, it's a whole bunch of triangles all mixed up like a little puzzle, and we have to find the measure of each numbered angle in the figure. So again, we might be able to go in order. We don't necessarily have to go in numerical order. I'm going to go ahead and start with angle 1. I usually try to start with the first one, and then I see what I get myself into. So angle 1 doesn't belong to any triangle. So because of that, I'm automatically thinking, all right, exterior angle here. So I'm going to try something first. So here, I could have this triangle, with that being the exterior angle. So that means I would need to add that angle and this angle. So what's wrong with that? Well, what's wrong with it is that the first angle I highlighted in green, I don't know that angle measure. So that's not helping us at all. So that's fine. It could be another exterior angle. So let's take a look at this triangle. So there's the triangle we're looking at. If that's my exterior angle, these are my remote interior angles. And when you know it, we do have both of those measures. So we know that the measure of angle 1 is equal to 32 plus 38. So the measure of angle 1 is equal to 70 degrees. Perfect, we found our first one. So I'm just going to continue going in order. So now we're going to look at the measure of angle 2. So the measure of angle 2, I see it right beside the measure of angle 1. And I see that combined they form that straight line. And a straight line is 180 degrees. And if the measure of angle 1 was 70, we're going to do 180 minus 70. And we find that the measure of angle 2 is 110 degrees. Okay, the other way we could have found it is we could have found this angle here, and we would have taken 180 minus 38 minus 32, and we would have gotten 110 degrees, and that 2 and that 110 degree angle, they are vertical angles. So sometimes you might have to find an angle that's not numbered to help you find the one that you do need to know. Okay. On to angle 3. Let's see if we can find this one. So the measure of angle 3. So we know this one here is 110. This one is 70. And that 70 degree one, or the 110, is going to come in handy So if I look at angle 1, which is 70 degrees, and this other one here in this triangle, they're vertical angles. So that means that is also 70. And now I know 2 of the 3 angles of a triangle. So I could say the measure of angle 3 is equal to 180 minus 70 minus 64. And we get that the measure of angle 3 is equal to 46 degrees. All right, we are moving right along. So for the next one, we can find 4 or we could find 5. There's enough information to find both now. I'm going to keep going in order, so we're going to find the measure of angle 4. So the measure of angle 4, the first thing I see is that, hey, it's part of this triangle, but I don't know 5, so I can't find that one yet because I only know one of those angles. So the next thing I look at is, okay, 4 is part of this straight line that's made up of that angle 4, angle 3, and that 32-degree angle. But combined, they all add up to 180 degrees. So I could take 180 minus 32 minus what angle 3 was, which was 46, and that should leave me with whatever's left, which would be angle 4. So when we do the subtraction, we find that the measure of angle 4 is 102 degrees. All right, and then for angle 5, it's our wonderful triangle sum theorem. So I can take 180 minus 102 minus 41. So we found that the measure of angle 5 should be 37 degrees. So just think about these as a bunch of little puzzles that you just have to figure out. All right, the last thing we have is 2 little corollaries before our last example. And this we did talk about in section 3.1. It says acute angles of a right triangle are complementary. So if we know that all angles are 180 degrees and one of them's right, that leaves us with 90 degrees to split somehow between the last 2 angles of a triangle. Doesn't necessarily mean they have to be split equally, but that it has to be split somehow. So it could be 30-60, could be evenly, could be 45-45, but it has to be split up in some manner. And 4.2 says there can be at most, keyword, at most, meaning no more than 1 right angle or 1 obtuse angle in a triangle. Again, we talked about that yesterday. So our last example for today is probably the easiest. It says the flower bed shown is in the shape of a right triangle. Find the measure of angle A. So anytime I see I'm given 2 angles of a triangle, I automatically know I'm going to use that triangle sum theorem, because we know the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180. So the measure of angle A we don't know, B is 90 because it has that little 90-degree mark in there, and C is 20. So we get the measure of angle A plus 110 is equal to 180. So we get the measure of angle A is equal to 70 degrees. We could have said also that since this is already 90, I know there's 90 degrees left, so I could have done the measure of angle A plus 20 equals 90, and then just done the measure of angle A equals 70. So a little bit shorter, and if you remembered this first corollary, that's what they're referring to, but either way we get the same answer. So remember, you do it the way that you understand the best. All right, so now take a moment, try the your turns, and then be sure to come back and check your answers.